Hi and welcome back to my channel. This problem this week is about finding the blue area, the blue hexagon inside of this larger hexagon. Now I want to start off the video this week by just explaining that last week's video that I put up, actually my solution wasn't quite right. And I think part of the reason that was down to is because I made up the problem myself, and so as happens when you make up some problems by yourself, you don't quite consider every single thing, and so there was a slight, a discrepancy really in the solution. In that there was something I should have considered which I didn't, and then that changes what the values were. So thank you for the people in the comments pointing that out. I do appreciate that. I'm human. Sometimes people make mistakes. But like I say, thank you for putting it down in the comments. I've hidden the video now because I don't want other people to see that and think that what I've said was right because I've missed something. Yeah. This week's video, or this week's problem, I should say, is not made by me. It's one that I've seen from somebody else, which I'll link down in the description below. So check them out if you want to see similar problems. They always seem to do blue areas, which is brilliant. But yeah, they put up loads of good problems every day, I think, which is excellent. So check them out. This problem is quite a nice one, I think, because it involves something which I don't usually use in the solutions to most of my problems, at least, anyway. Yeah, so what I'll say is, of course, as always, you can have a go at it yourself. I am going to go through my solution. Pause the video now if you want to go through it yourself, because I'm going to go through my solution in 3, 2, 1. Okay, so this problem, like I said, is a really nice problem, and the reason why I like this problem is because, well, it involves angles, but not really that, because it involves symmetry. I really like the symmetry of this problem. And the first thing I wanted to do with this problem is to put all the lines of symmetry on this shape, like this. Now, what that helps me, and probably you see, is that we've got lots of repeating shapes all over the place. And actually you can investigate that and make sure that you believe that they are the same shapes all over the place. And so you can do that by looking at angles and triangles in loads of different places. And what happens is you quickly realise that actually they are, so like this is the same as this is the same as this, and so on. All of these triangles are equal. They've got the same angles and they've got the same lengths involved. Okay, so all of these are equal, and that's the really really great thing about this problem, is the symmetry of it. So what I can start doing is, well, counting up how many of these different triangles there are, and actually there's 36 of them. Okay, so 36 of those, and out of those 36, how many are blue? Because then we can then use that as a fraction of the total, or the fraction of another triangle, the blue amount, working out an area via that, basically, using fractions of our triangles and the areas of those triangles. So there's 12 blue ones out of 36. Now, the next thing, like I've said there, is we need to work out an area of some triangle here, and then we can use that to find out, well, whatever fraction of that triangle is blue, that area, and then the total blue area. So the next thing that I'm going to do, and like I said at the start here, explaining my solution, you could check these are the same by looking at the angles. What you will realise is that if we look at this triangle here, the one I've just got rid of the circles in, we've got a right angle here, and if you look at or try and think about now the whole hexagon, or any hexagon, any regular hexagon, the angle, the interior angle, you can work that out using this formula, n minus 2 times by 180 and divided by n. Okay, now obviously n here is going to be 6 because we've got 6 sides. So 6 minus 2 times 180 will give us the sum of the interior angles, and then if we divide that by 6, we will get the interior angle. And the interior angle of any hexagon is 120 degrees. So this whole thing here would be 120 degrees, that whole angle. Now, again, because of the symmetry, that angle is going to be split in half. And what that tells us is that this angle that I'm drawing on is 60 degrees, because half of 120 is 60. Now we know that's 90 because it's going at right angles, so this must be 30. Okay, now you can see, hopefully, which triangle I'm looking at here, the one with the angles drawn in. And we've got one blue section there out of 3. We know the base of that triangle has to be 3. Okay, now from there what we can do is we can start using some trigonometry. So I'll just clear this up. And the trigonometry I'm going to use, you could use anything really, because we've got all the angles. We've got 30 and the 60. I'm going to go with the 60, and I'm going to do opposite and adjacent. So it would be tan. And actually I said you could use anything, but it would always be tan, wouldn't it? Unless you worked out, yeah, it would have to be tan. Unless you worked out your hypotenuse first. Right, so tan, let's go with 60. Tan 60 is equal to, well, tan is opposite over adjacent. If I'm looking at this or using the 60, opposite, I'm just going to leave as opposite. That's going to be the perpendicular height. Over, I'm leaving this fraction here purposely for later, so I haven't forgotten about it. Tan 60 equals opposite over adjacent. Adjacent is the 3, so that means that 3 times tan 60 is equal to the opposite. Okay, and that gives us an answer for the opposite of being 3 times tan 60, which is 3 root 3. And so that's the height of this triangle. Now, just in case you're not sure, I'll try and do some highlighting with a colour that is going to stand out here. It's going to be a bit tricky. Let's go with a black colour. So we're looking at this triangle here, okay? That triangle, just to make it a little bit more obvious. Okay, so a height there is 3 root 3. What I then need to do is base times height and half it to get the area of the triangle. So I'm going to do, excuse me, I've got a bit of a cold this weekend anyway, it's come on this week, as probably most people in the UK have at the minute. A half times 3 root 3, and that's the area of this triangle that I've gone round and outlined in black. That's going to give me 9 root 3 over 2. Just scroll down ever so slightly. 9 root 3 over 2, and that's the area of that triangle. Okay, right, I'm just going to clear that a second. So 9 root 3 over 2. 9 root 3 over 2, remember that? 9 root 3 over 2. 9 root 3 over 2. So I want 12 over 36. Well, that's actually, we need that for later. We don't need that just yet. We need a third of, what was it? 9 root 3 over 2, that's it. A third of 9 root 3 over 2, because we've got one that's blue out of 3 triangles inside this black outline triangle that I've done. So 1 out of 3 of those is blue. I'm working out the area of this blue section inside my triangle. So a third times that gives me 9 root 3 over, well, 3 times 2 is 6. Can simplify that, so that gives me, well, I could just do 9 divided by 3, couldn't I? 3 root 3 over 2. And, okay, so that's one of them. Now, actually, like we said earlier, there's 12 out of the 36, so I need 12 lots of this. So I need to do, I can get rid of that now, that was just a note to myself, 12 times 3 root 3 over 2. 1, 2, 3, let me check this, 1, 2, 3, 4, 5, 6, yeah, there's 12. So 12 times 3 root 3 over 2, that's going to be 36 root 3 over 2, which is equal to 18 root 3, which is the final answer. So the area of the blue section here is 18 root 3, which I think is quite a nice solution. And I suppose to extend that problem, what would it be if we made it into, you know, the length at least of the outer hexagon, not 6 but n? What would it be then? That's a problem to think about, wouldn't it? Because surely you'd be able to do a similar thing. What's the relationship? Yeah, that might be interesting to have a look at. Is it as simple as 3n root 3? I don't know, there's a question to think about. Thank you for watching. I hope you enjoyed that, and I hope if you tried it yourself, you were able to get an answer of 18 root 3 as well. If you did enjoy it, please drop a like on the video, consider subscribing to the channel. I really appreciate all the support, the comments, and everybody that has subscribed to the channel so far. And I will see you next week for another video. Have a great week, everyone. Bye-bye.